This is going to be a very detailed video about set theory. We'll talk about surds, complex numbers, irrational numbers, and binary operations. So if you are new to these concepts, I'll explain them. So you can see everything is going to be covered under sets. Okay. And then we have dealing with the conversions of like decimal numbers to rational numbers. And then we have like irrational numbers. Yeah, so about right. And then we have like those simple basic complex numbers. Then we have surds, binary operations at the end. So if all these concepts are new to you, watch a video till the end and you'll be able to understand them. So we'll start from question 1. So question 1 reads, so we are told, of course, our set A is consisting of 2, 3, 4, 5, set B 2, 4, 6, 8, set C 3, 4. So we call this roster form for your own information. And then we've been told our universal set is consisting of numbers 0 all the way up to 10. So in case you are new to this, a universal set is actually a set that gives us all the elements under discussion. Okay, so a universal set is like, if you think of it as sets to be countries, and then you kind of like think of a universal set to be like the globe. Okay, so this is like a Venn diagram representation of what it is. So this box is going to be called the universal set, and then everything else inside would denote the other sets. That's exactly, but I believe that is easy for you to make that presentation. So we need to verify the associative laws, distributive laws, the De Morgan's laws. So for your own information, if you basically don't know what these laws are, you can watch a video. Okay, so the link has been put in the description where I've summarized all the laws under set theory. Okay, so I'll just focus on verifying these laws. I'll start with the first one. Okay, so what I'll do is I'll verify one side, and then for your practice you verify the other side. Okay, so I'll start with the first one. I'll verify the left hand side. So we've been taught our A intersection B intersection C is equal to A intersection B intersection C. So these are very easy to remember. Just make sure you check out the video I've explained all the laws. So BODMAS tells us every time you're simplifying, you need to start with what is in the brackets, right? Okay. So the first one is requiring us to simplify B intersection C on the left hand side. The right hand side is A intersection B first of all. So I can show that on the next step. So my B intersection C is equal to, so B intersection C, you're looking at the common elements between B and C. So I can see we have 4 and 6 as our common elements. And then for the right hand side, of course, we are expected to focus on A intersection B in the brackets. So if you compare A intersection B, I can see 2, 4 are common. Hope I'm right. So we've simplified what is required in the brackets. So verifying. So there are two ways of verifying. One way is by deciding to begin with this. I'll say my left hand side, which is equal to A intersection B intersection C. So I've just like copied that and pasted it down there. That is the left hand side. So simplify it. So we have A outside. So I'll just list set A. Set A, according to the question, is having members 2, 3, 4, and 5. intersection. Now in the brackets, B intersection C has already been found, right? Which is 4 and 6. So as a good student, you can even list it just here so that they're able to see it. Oh, okay, 4 and 6. So there we are. So we are interested in finding the intersection between this and that. So what intersection do we have between the two sets? So I can clearly see that only 4 is common for me. So what is for the left hand side? Now shift, I'll just go to the right hand side. Don't forget our answer is 4, yeah? So for my right hand side, we add that part. A intersection B intersection C. So your A intersection B, which has already been simplified, is 2 and 4. And then intersection with C, your C is 3, 4, 5, and 6. What's common between the two sets? It's as well as the first one. So it is also 2. So it's as simple as that. So we are now ready to move to the other part of the question. So I'll show you by looking at the other side. So feel free to pause the video and try out the other associative law. A union. So that is the question. So I'll not copy it. I'll just go direct. So the other way of verifying this is you just copy it as it is. Okay. So after you've copied it, so I'll consider I've copied it down. And then I'll simplify the ones that are in the brackets. So in the brackets we have B union C. So I'll start with B union C on the left. So B union C, union means you combine all the elements together. So if you look at B and C, combining all the elements together. So if I look at both sets, I look at 2 to be the smallest number. And then from the other set, I have like 3, 4, 5, 6. So I'll continue 2, 3, 4, 5, and 6. And then like in this other set, there's an extra bigger number, which is 8. And then which other one do we need? We also need A union B. So I can just write it somewhere as well. A union of B. So if we are combining our A and B, we have 2 as well. So set A is moving all the way up to 5, and then set B has got extra 6 and 8. 2, 3, 4, 5, 6. So like we just like getting the same thing, right? Yeah. So those are the two sets we had in the brackets, that part and that part. So now I'll show you the other way of verifying, where you just like copy it all at once and the like. So you have like A union B union C as a left hand side, and then your right hand side you have like A union B union C. So this is like just like paste whatever you have. So for A we have 2, 3, 4, and 5 union. Now B union C is what we have found now. 2, 3, 4, 5, 6, and 8. And then on the right hand side, A union B is what we found as well. So we have 2, 3, 4, 5, 6, 8. Now union C. C is what? 3, 4, 5, 6. So I don't have enough space here. 3, 4, 5, 6. Yeah. So on the left hand side, if I begin to combine, so 2, 3, 4, 5, they're already part of that set, so I believe it will just be the same. 2, 3, 4, 5, 6, and 8. And then the other part, 3, 4, 5, 6, 3, 4, 5, 6, which are also already part of that. So you can see that the left hand side and the right hand side are equal. So left hand side is equal to right hand side, hence verified. So verifying is as simple as that looks. Okay, there's nothing to think about. No, how do I go about it? So for the distributive law, we're now on the distributive laws. You can also apply the same concepts and try them out. So we have, for the first one, A intersection B union C. So that is my left hand side. Okay, so now there's need for me to find B union C. What is B union C? I combine B with C, so we'll have 2. So look at these two sets, B union C. So I have 2, and then I've got 3, 4, 5, 6, and then I go back to my set B. There's a bigger number there, 8. So that is our union of the two sets. Now continuing, we need to find A intersection that. So my set A is 2, 3, 4, 5. So as a good student, you can even say set A, you list it there, so that as you are resting on the next step, the marker is able to follow up. So you have your set A there. Now intersection with B union C, which is 2, 3, 4, 5, 6, and 8. We need to find the intersection. What's the intersection? So I can see 2, 3, 4, 5. What are the common elements? There are 4 common elements, 2, 3, 4, 5. You can take note of that. So quickly go to the other side. Don't forget 2, 3, 4, 5, 6. So we'll go to the right hand side. A intersection B. So if you don't know how to remember these laws, I would advise you watch that video. The link is in the description about the laws on set theory. So in this case, we've got 2 brackets. So I'll simplify them on the next step. A intersection B is equal to, what are the common elements between A and B? So I can see 2 and 4. A intersection C, A and T. A and C. 2, 3, 4, 5, 3, 4, 5, 6. So I can see 3 is common. I can see 4 is common. I can see 5 is also common. On the next step, we can go back with our right hand side. We need A intersection B, which is 2 comma 4, and then we need a union, and then A intersection C, which is 3 4 5. So if you go combine these, you have 2 3 4 5. So by the way, when when you have got a common element as you're coming up with a union, you only write that element once. That's why I've written 4 once. So this matches up with what we had with our left hand side. So you can make a conclusion to say hence proven or hence verified in respect to the question. So the other one is for your own practice. Same principle applies. Begin with what is in the brackets. Follow all those steps. You'll be able to verify by getting the same answer. I'll get one from the last part on the De Morgan's laws. So A union B, A union B, complement, that's the left hand side. So the way I like breaking down questions is I would want you first of all to focus what is inside the brackets, which is as A union B. You can list it out. A union B is, so that means you combine A with B, right? So if we do that, we'll have 2 3 4 5 with an addition of 6 and 8 from B. Now the complement of that, so first of all I simplified A union B. Now the next step I'll say now complement of it. Remember that is what the left hand side is equal to. So complement means exclude the list of elements you have from that set. What remains in the inverse set is what gives you the complement. So if you look at 0 1 2 all the way up to 10, that is our inverse set. Now exclude 2 3 4 5 6 8, which makes up the union of A with B. We're going to remain with 1, 2 is there, 3 there, 4 5 6, so I can see 7 is missing, and then after 8 we have 9 and 10. There we are. So that is our left hand side. We can quickly go to our right hand side. So for our right hand side, we have A complement intersection B complement. So I'll start with A complement. A complement means exclude set A from the inverse set. So in set A we have got 2 3 4 5. What remains in the inverse set? Of course 1 is missing. 2 3 4 5, and then 6 8. Do we have 7 there? No. 6. Why have I said 8? I'd have skipped 7. 6 7 8 9 10. And then B complement. I'll exclude the B elements. So in B we have got 2 4 6 8. So 1 is missing, 3 is missing, 5 is missing, 7 is missing, 9 is missing, 10 is missing. Okay. So we need to find, now the right hand side is equal to like the intersection of the two sets. So what is the intersection between the two sets? What is common? I can see 1 is common, I can see 7 is common, I can see 9 and 10 are also common. So we have 1, 7, 9 and 10. So you can clearly see that the left and the right hand side are the same. So you can make that statement: left hand side is equal to right hand side. Therefore, verified, or hence verified, depending on what you can say yourself. So pretty much you can also work on the other one on the right hand side. So you've got 2 questions that I've not answered that I believe you can work out based on what I've given you so far. We'll continue now with question 2, which is from set interval notation. Of course, the good part about it is we've got a case where the real numbers is the universal set in question B, and then this other one is limited between -10 to 10. So we'll give to understand more in details. So if you are new to this concept, I would advise you watch the video about it, link in the description, and is appearing right now on the screen. Okay, so we can move. So for your information, the question says let X be the universal set. So that is our universal set. So just to give you an idea in case you are new to this, hoping you've watched the video, the way it is set interval notation deals with presentation of sets that are dealing with real numbers on the number lines, because we can't basically get to list all the elements in roster form because we can't count the elements. So we'll just present it as an interval on a number line like that. So this is basically our universal set, -10 all the way up to 10. So that only applies to those kinds of brackets, the curved ones. I call them curved. In a case where we change brackets like that, we are supposed to shade inside. Okay. Now it is also possible that only one side can be shaded. Okay. In such a case, that changes. It becomes curved on the left hand side. So you're able to see that there's a correlation between unshaded and the curved bracket, and then a square bracket with a shaded part. So the square bracket and the shaded part denote that this element is part of a set. On the opposite side, it is not. Okay, so you now understand what the notation stands for. We can now go and answer the questions. So we are told to find, for the first part, a complement. Now they need us to find the set and then also display it on the number line. But the way I approach the question is I start with a number line because that's a simpler way or a faster way of approaching the question. So they want us to find a complement for the first part. So the set itself A is -2 to 6. So we'll say -2 all the way up to 6, something like that. So we'll display it there first. So is there any part that we need to shade depending on the notation that we have? So we only have curved brackets, implying both -2 and 6 are not part of set A. So we have our set A there. Now, the complement will begin from both its ends all the way up to the end of the universal set. Now, this universal set we have is ending. Okay? It's ending. So on the left hand side, of course, we know it's ending on -10. -10. And then on the right hand side is ending on +10. That's where the universal set is ending. Pay attention to that. So what we do to the ends of what we have depends on the universal set. So in this case, our universal set at the end is not shaded. So we'll leave it open like that at the end based on the universal set given. So if we had these brackets at the end or any end, we are going to shade that end. For example, what I've written down would have shaded the left part because it shows -10 was going to be part of a set. Alright. Now, how about the middle parts where the complement set is starting from? What happens there? So the notation that we have tells us -2 is not part of a set. So we'll shade inside. Sorry, it is not part of a set. So we'll have to shade the complement set to show that it is part of a complement since it is not part of a set. Equally on the other side, we'll basically get to do the same. Okay? So it is either an element is part of a set or part of its universal set. That's why if you look at this not kind of notation where you say A complement intersection A, this is expected to be an empty set because it's either you're inside or you're outside. So if negative 2 and 6 are not part of A, they will instead be part of its complement. Now it's also possible that one side may be part and the other side may not be part. Of course, all based on the notation given. So I'll label that now to be our A complement. So we've presented it on the number line. Okay. Presented on the number line. So all those are just things I was trying to use to help you understand or get the basic idea. But that's it. So displaying the set now, writing it down. Of course, the complement here is starting from negative 10 all the way up to negative 2. Now paying attention to whether we've shaded or not shaded. Negative 10 is of course not shaded. Negative 2 is shaded, so I'll use that kind of bracket. Now I'll use union to join them over from 6 up to 10. Now 10 will be curved. So this is our A complement. Now of course I'll not remove that deliberately. I'll go to the second part of the question, which is dealing with x minus A. Now x minus A. Now x in the question denotes the universal set. So if you are removing any set from the universal set, it is what remains is a complement of that set. Okay? If you are removing any set from the universal set, what remains is the complement of that set. So in this case, I believe x minus A is just as good as A complement. So I don't expect a difference between the first and the second question. Okay? Of course, some of you are already saying, no, what? So x minus A, if you go by the notation that has actually been come up with, it more like an identity, it is the same as x intersection A complement, right? That's like what we have here. So what is an intersection of any given set with a universal set? Remember, the universal set is made up of everything. So is there any intersection between a given set and the universal set? Every set is part of the universal set. So whatever set you intersect with a universal set, it will be that set itself. So it will still be a complement. So there is no way we can run out from the fact that the first one and the second question were basically one and the same. So you can just do the same. So first of all, if you are given something complex, I would advise you simplify it before you begin presenting it on the number line. Otherwise, you may get confused along the way. So I'm now on the third one, which is A intersection C complement. So copy it, A intersection C complement. What does that mean, first of all? So just like I started simplifying other things, so I'll begin first of all by presenting A intersection C before I can get to A intersection C complement. So that's the way I like moving step by step. So I'll consider what is in the brackets. Now for me to find the intersection C, I need to find both A and I need to present both A and C on the number line. Now A is from negative 2 to 6, negative 2 to 6, negative 2 to 6. So I'll take that to be my negative 2 all the way up to 6. That is my set. My set A. Now join them. Both negative 2 and 6 are not shaded based on the interval given about A. And then I'll straight away go to present my set C. C is from negative 1 to 8. So negative 1 is obviously somewhere here. 8 is after 6. So that is the expected set. Is it shaded at the end? Of course, negative 1 is supposed to be shaded based on the interval I'm seeing there. So 8 will not be shaded because it's curved. So how do we find the intersection? So the way we find the intersection is by shading. So I'll shade the common region. So I'm saying this region to be the common region. That is a common region. Okay, that is our intersection. So if I was to present on the number line what the intersection is, it would move from -1 all the way up to 6. Okay, -1 all the way up to 6. Now that would include -1 would be in that kind of bracket, and then 6 would be in a curved bracket. So we consider the end part. So this part I'll get that, for the other part I'll get that for the intersection. So -1 to 6. So the meaning there is -1 is common between both sets. Then the meaning at the end shows 6 is not common. And of course it is true, because 6 is not part of set A, because it's not shaded at the end. So that's basically what you do. Okay, so this is our A intersection C. So now that we found our A intersection C, we are now capable of finding the complement, its complement. So its complement, obviously, I can show it on the second number line, right? So I can come up with another number line. Something like that. And then, so -1 up to 6. That's what I've said is our A intersection C, which we've simplified from the first number line there. So don't forget, what is the part that is shaded is only the -1 part. Okay, that part, this region I've shaded, remember, is the one we are discussing here. So this is our A intersection C. So its complement would be just like we handled A complement. So from this end all the way up to the end, and from this end all the way up to the end. Now don't forget that the end 10 and -10 respectively. So where are we supposed to shade and where are we not supposed to shade? So at the ends we'll not shade because we are looking at our inverse set there that was given. And then at these ends we'll do the opposites. So that is already, one side is already the opposite. So on a part where it is not shaded, we'll shade to show that 6 is actually part of its complement. So that is A intersection C complement, and then that is also A intersection C complement. So that is on the number line. Now we can also present it in our own notation. So from -10 it is not shaded all the way up to -1, and then I'll use union. Now from 6 it is shaded up to 10 is not shaded. So I'm just focusing on the either with shaded or not shaded to come up with that notation, and I believe that is okay with you. Right, so we're now ready to move on. We're now on 4, which is B minus A intersection C. B minus A intersection C. So you can try that one out, and if you're tired you can drink some water, pause the video, even just 5 minutes of moving about, and then get back to your desk. You don't have to punish yourself. Okay, take your time. So what does B minus A mean? B minus A means B without A. Okay. So well, how do you present that on the number line? So we'll make it as interesting as possible. So we'll do this. So I'll draw a number line. So remember, we're always starting parties in the brackets, right? B minus A. So B minus A means B without A. So we're interested in our B. So our B is -5 to 3. -5 to 3. So negative 5 all the way up to 3. That is our B. Now B is not, it's shaded actually, it's shaded on both ends, negative 5 to 3. Interesting. So negative 5 to 3 shaded at both ends. So that is our set B. And then I'll present my set A, which we are expected to remove. Now set A is from negative 2, which I believe is somewhere here, all the way up to 6. So 6 is after 3. So negative 2 and 6. And then we have it there, like that. So that is our set A. So I want you to get this one so clear and so basically. That is our A. We have our B. So if you look at A is not shaded on both ends, negative 2 and 6. Now if we are saying B minus A, B minus A, B minus A, what exactly does it mean? It means remove A from B. As simple as that sounds. So the way I do it is I'll just shade the common region. So this part is the region that is common. Okay? So we'll remove the common region from B. Okay? Why are we removing it? Because we are removing every part of A from B. Now if I remove that part, if this part that I've shaded moves away, what remains is B minus A, or B without A. So that means that our B will move from negative 5 and end at negative 2. Now the question is, will negative 2 be shaded or not? So if you check your A there, your A at negative 2 there is not shaded, which implies that we are not taking away the negative 2 because it is not part of A. So it's remaining to be part of B. That's why you have to be smart now. Remember, you're doing the opposite. So this part is going to be shaded to show that negative 2 has not been taken by A, because it is not part of A. Essentially, look at the question, negative 2 is not part of A. So we've not removed it from B. It is still there. So therefore, what remains as our B minus A is from negative 5 to negative 2. So I've removed this region because it is part of A as well. Maybe we can use the same number line. I hope you've taken that, you've gotten that. If you've not, I would advise you to play it back. You play the video again. So, what about if we think about it in the opposite? What if it was A minus B? What would be different? What if it was A minus B? So if it was A minus B, it would mean we are removing B from A. So this same part would be taken away. Now what would remain is this part all the way up to 6. Now, that part would not be shaded because 3 is indeed part of B. So it's actually being taken away from A. So we would have 3 to 6. None of the sides being shaded as our A minus B. So A minus B and B minus A, ladies and gentlemen, are not the same. The meaning is not the same. So anyway, B minus A, I'm removing the A and remaining with B minus A. So I've removed B. I've removed A actually. So I've remained with B minus A. Now we have B minus A. We need to find an intersection with C. Now C, according to the question, says it's from negative 1. Now negative 1 is supposed to be somewhere here. Negative 1 is somewhere here. All the way up to what? All the way up to 8. Okay, let me just put 8 there. This is where we have 8. So which part are we shading of C? Oh, negative 1, of course, is being shaded. That's our C. Intersection, very visible. The part where they are overlapping. Now both ends are shaded, right? Yes. So you can present that on a number line, right? So it's as simple as what's the expected result there. So it's from -1 all the way up to -2. -1 all the way up to -2. Okay. -1 all the way up to -2. That is our B. That is our B minus A intersection C. So presenting that would say -1 to -2. So that's it for that question 4. I hope you know how to deal with the minuses or the subtraction of the differences of sets. We're now on number 5. I know if you're tired, if you're doing this for the first time, I believe you're very much exhausted and you feel like you're not understanding anymore. Just pause the video and continue a bit later, or even after 5 minutes, or 10 minutes, or even an hour. Still fine. It's meaningless to finish a video and not understand. Anyway, I was taking my coffee. I'll continue. A intersection B minus C. What do we need to know here? So you know every information that is helpful for you to answer this question. So just like question 4, these two questions are almost the same. So you can pause the video and try it out. So we'll start with B minus C. Always start with what is in the brackets. I recommend. So set B is from -5 to 3, -5 to 3. And then the other one is from -1 all the way up to 8. Yeah, pretty much. So I'm just trying to draw them. So we have, so -1 to 8 is set C, supposed to be shaded on one end, which is -1. So this is set C, and then the other set, which is B, is from -5 to 3, shaded at both ends based on the kind of brackets I'm seeing there. Now if we are to find B minus C, what did I say? I said first of all shade the common region, the overlapping part. Now you're finding B without C, so remove that intersection region. What will remain of B is the answer. So if we do that, would remain with B from that point to that point. So since this part is shaded, it is going to be taken away from B, so B will be unshaded at that part. So yes, that's what to do. If it was C minus B, would remain with this part going that side for C, but this is B minus C, so we're removing the C, so the C is being taken away, and that is what remains of B. That's what remains of B. B minus C. Good. So now we have a B minus C. We can just find this intersection with A. Set A is moving from -2, which is somewhere there, approximately up to 6. 6 is after 3, of course. Not shaded at any point. So intersection is this region. So at both ends it's not shaded. So therefore the expected result is only between -2 and -1. But how is it the case again? How is this the case? Wait. -2 up to -1 is our intersection between set A and B minus C. Set A is from -2 to 6. B minus C, after removing C, we've remained with that. Okay, yeah, that's still fine. So the answer still remains -2, -1. So of course they're not shaded at both points. Yeah, so that's the way you're looking at this one. Now we are now on the last one that looks complicated. It's actually easier. For me, I look at it to be the simplest one. So we are remaining with one more on set A, on part A, and then we can actually move to part B. So don't get tired. Of course, there are more questions coming, so we still have a long way to go. Don't get tired. So you can watch this video at different times. X minus C complement intersection A minus B. How do you simplify this guy? So I said start with what is in the brackets first of all. So what does X minus C mean? I already explained that. So X without C. X is denoting the universal set. So the moment you remove any set from the universal set, what remains is the complement of that set. So therefore, in that bracket, I would have C complement because I've removed C from the universal set. Now there's another complement outside. Intersection A minus B. C complement, we have C now. Intersection A minus B. This is what I was saying. There's nothing unique about this question. It just looks complicated for nothing, actually. Yes, for nothing, actually. For no reason. What happens now? So now at this point, I want you to simplify it. Pause the video, simplify it. So for me, I'll start with what is in the brackets as usual. I need to find first of all A minus B. So if you try to expand the A minus B as A intersection B complement, you waste a lot of your time. A minus B is faster. So remember your A is from -2 all the way up to like 6. Okay. And then the other guy is like all the way from like -5 all the way up to like 3. That is for set B. So we've got to take a line there. And then I'll draw a line for A. So don't forget that these guys are supposed to be shaded. -5 to 3 is shaded for set B. And then for -2 to 6, which is like set A, is basically not actually shaded, right? Yeah, pretty much. That's what we're saying there. So what then are we saying? So we're now saying, well, the fact of the matter is that these two guys are to be subtracted, which is A minus B. Now we're removing the intersection part. So this is the part that is overlapping between the two sets. We are removing B from A. What remains of A is what? This part going that side. So the fact that B is shaded at that part will imply that this part remains unshaded of A. because we've removed that element 3. So what remains of A is 3 to 6. So this entire part goes away. B has taken it away. Alright. So that's where our A is remaining now. Like that. So that is now our A minus B. Now we need to find an intersection with C. Now C is from -1, which is somewhere there, all the way up to 8. Wow. So if you draw it like that, and then remember -1 part is shaded. So what are we saying? That is our C. What's the intersection? What's the intersection? So intersection is this region. That's the intersection. Now the determinant part is the one that is short. So in this case, A minus B is open at both ends. So that tells us we are going to have an intersection just being A minus B. So in this case, our answer is from 3 all the way up to 6. So not shaded. You can present that on the number line, which I believe you are more than capable to do it. Yeah, so that marks the end of question 2, which was looking complicated. It's not as complicated as actually exaggerated. It's very simple. So we're now on question B. Given that in this case now the set of real numbers is like the universal set. So this one they like it a lot, so make sure you pay attention. Remember, if you're tired, pause the video. So -8 to 6, that is our set. 5 to infinity for B. So quickly, I'll answer a complement. So set we're now dealing with the concept of the subsets. So if A is a subset of B, then simplify the following. So the best way we can approach this question is I'll do this. Set A is a subset of B. So that's what it means. It means A is in B, I believe. A is a subset of B. So this is our A. So we'll be using that diagram to help us simplify. So if you look at that set, what is common between A and B? So the fact that A is part of B, what is common between A and B? Think of it just directly. A intersection B, what is common there? So A is contained in B, so I believe A is common. Okay, quickly we got the second one. A union B. A union B, that means you combine A with B. So if you combine both A with B, ultimately what you have is still B. You can't get anything bigger than B because A is already in B. I'm just trying to help you think fast. The third one, we have A complement combined with B complement. So let me introduce the inverse set now. That's our inverse set. Now B complement means you shade the region outside B. So what is B complement? Now we are also taught to say together with A complement. A complement also means you shade the region outside A. So at the end of the day, you will notice that the only part that is not going to be shaded is the inside part of A. So therefore, it's just simplifying the answer as same as just A complement, because A complement will also include B complement. Yeah. And then for A intersection B complement, A intersection B complement. So what is outside A? So I'll do that again. So what I'll do is I'll shade B complement. So B complement, I'll use green to shade B complement. What is outside B? Now also use yellow to shade B complement, or A complement now. So A complement. So there's one thing that you're noticing there. You're noticing the fact that set A is actually also including the complement of A is also including the complement of B. So what is common between the two? Like what is basically common between A and B? So for me, I can say, where are they meeting? Like where are these lines meeting together? The green ones and the yellow one. So they are meeting outside B. So I feel B complement is like common because it is part of A as well. A complement is also involving B complement. Just look at the diagram. The green lines, A is all the way from the inner part of B to the outside. B is just from B to the outer part as well. Now, when you say A complement intersection B complement, you can just simplify it as just B complement. Because like what is common between A and B, A complement and B complement is B complement itself. Yes, because that's where the lines are meeting, outside B. And then finally, the last one is not actually the last one. Number 5 is what? That's like A complement union B. So A complement union B, what does that mean? Let me try to create another. So we have A and then B. A complement. So A complement of course means outside A, which is this region, outside A. And then you are combining it with B. Now I said B is this region. So B is actually involving everything that is including A, because A is part of B, interestingly. So that is set B in blue. And then set A complement is everything outside A, which has reached now even the Venn diagram. So I feel when you combine everything, it's like there's nothing that is that has remained unshaded. So I feel that is equal to the universal set, because A complement is everything outside A all the way up to the Venn diagram, and then B is including everything inside, including A itself. And then finally, we have the last one, A intersection B complement, which is as good as A minus B. Maybe I can just undo the shading. Okay. So the final one is A intersection B complement, which is the same as A minus B. You remove B from A. So let's think of it now. Is it possible that we can remove B from A? Because remember, A is part of B. So if you can remove B from A, then for me I feel it should be an empty set. Because A is actually part of B. So what if you remove B? You are removing all the elements, so it remains an empty set. Think of it this way. Let's say our set B, which is of course the power set. Is it the power set? Not necessarily a power set. So it's a subset and a superset. So B is a superset. So let's say we have 1, 2, 3, and 4 as our set B. And then we have a subset of it to be, let's say, 2 and 4. So if you say B minus A, all the elements that are in, actually it's A minus B. So if you say A minus B, your A is 2 and 4. So you need to remove all the elements that are common. The intersection between the two sets are 2 and 4. So it will be an empty set. Yes. So pretty much. So you've seen that by using the diagram, it's actually easier to simplify whatever questions we are actually given there. Now disjoint sets, equally as well, you can draw them. So these are sets where I don't have like an intersection. So that is what are examples of disjoint sets. So we'll label them to be A and B respectively. So as shown, A intersection B is an empty set.